In this video, we are going to look at the reactivity of elements in groups 1, 2, 17, and 18. But first, I want us to look at the similarities in the chemical properties of elements in the same groups. What is the relationship between chemical properties and electronic structure? Elements in the same groups have the same outer electronic structure, and therefore they have the same valence electrons. So as you can see, all group 1 metals or alkali metals have a valence electron of 1, and as you can see, they all end at s orbitals. The only difference is the outermost energy level. For lithium, the outermost energy level is 2, for sodium is 3, and for potassium is 4, but the valence electrons are the same. Same applies for the alkaline earth metals. They have valence electrons of 2, and they also have their outermost energy levels ending at the s orbital. The only difference is the outermost energy level. Same applies for halogens and noble gases. Noble gases have an octet structure with a maximum of 8 valence electrons. Remember, noble gases, they have a completely filled outer energy level. It represents a very stable electron structure. According to the octet rule, other elements or other atoms react in such a way as to acquire the closest noble gas structure. So that is why some of them, they prefer to lose electrons and some of them prefer to gain electrons, because they want to achieve or acquire the closest noble gas structure. The number of bonds an atom can form will depend on the number of valence electrons. For example, group 1 and 2 elements can acquire the preceding noble gas structure by donating their valence electrons and forming positive ions. So for group 1 and 2 elements, it is very, very hard for them to want to acquire the structure of the next noble gas. For example, for lithium and beryllium, it is very, very hard for them to want to acquire the structure of neon, but it is very, very easy for them to want to acquire the structure of helium, because helium is the closest noble gas to these two elements. That is why then lithium prefers to lose one electron so that it can acquire the structure of helium, and also magnesium prefers to lose 2 electrons so that it can acquire the structure of neon, which is the closest noble gas to it. In the group 17 elements, they can acquire the structure of the following noble gas. So for example, chlorine and fluorine, they prefer to lose they prefer to gain 1 electron. For fluorine, it prefers to gain 1 electron so that it can acquire the structure of neon, and chlorine, it prefers to gain 1 electron so that it can acquire the structure of argon, and also sulfur and oxygen. So sulfur prefers to gain 2 electrons so that it can acquire the structure of argon. But sometimes we do not get the losing and gaining of an electron or electrons. We just only get sharing of electrons. And we're going to look at sharing of electrons when we get to chemical bonding. Let us now get to the reactivity of elements in groups 1, 2, 17, and 18. The reactivity of an element measures how forceful an atom of the element reacts with atoms of other substances. This will depend on the ionization energy, that is how easily electrons are removed from the atom, and electronegativity, which is how strongly the atom attracts electrons to itself. The reactivity of metals decreases from left to right in the period and increases down the group. So as you move from left to right in your period, the reactivity decreases. This makes sense because you remember that noble gases, their reactivity is very, very low. Why is that? Because they already have a completely filled outer energy level, and the reactivity increases as you move from up to down the group. But the reactivity of the halogens decreases as you move up to down the group, so you should remember that. Let's look at group 1 elements, which are alkali metals. What are the properties of these elements? They are soft metals with a shiny metallic appearance. They have low densities, so they float on water. They are good electrical and heat conductors. They are very reactive, and therefore they do not occur freely in nature. And they are stored on the oil because the reaction of these metals can cause explosions, and you don't want explosions happening to you anyway. They burn fiercely in oxygen and form metal oxides. You remember when we did the oxides? And they form hydrogen gas and metal hydroxide when they react with hot water, which is the explosions that I'm talking about, the violent reactions that we do not want. So that is why they do not occur freely in nature. They have a low first ionization energy, so they require little energy to donate the valence electron and form a cation. Their reactivity increases down the group because the ionization energies decrease down the group. Let's move on to the alkaline earth metals. What are their properties? They have a silvery appearance. They are good thermal and electrical conductors. They are not as reactive as alkali metals and can be stored in their element form in sealed containers. So they do not react very violently. So we can even store them in sealed containers. Remember, the alkali metals, we need to store them under oil mostly because their reactions are very, very violent and dangerous. They react slowly with oxygen in the air and form metal oxides. If lit in powder or ribbon form, the reaction with oxygen is much faster. The reactivity of the reaction with oxygen increases down the group because the ionization energy decreases down the group. The reactivity with water increases down the group, and they react with water to form hydrogen gas and a metal hydroxide. As you can see, when calcium, for example, reacts with water, we form a calcium hydroxide and a hydrogen gas. The halogens, which are the group 17 or group 7 metals. What are their properties? Halogen atoms of the same element combine in twos to form diatomic halogen molecules. For example, your chlorine and your fluorine. They are yellow-green gases at room temperatures and are very poisonous. Bromine gas is bromine, Br2, is a red-brown liquid, and it is very volatile, so it evaporates easily. I2 has shiny dark purple crystals that sublimate easily at normal temperatures to form purple fumes. They are nonmetals. They have low melting and boiling points. The atomic the radius as well as melting and boiling points increase down the group. They have high electronegativities and they have 7 electrons and can attain a noble gas structure by accepting 1 electron and forming anions. Remember, I said that they want to acquire the structure of the following noble gas, and this is much more easier for halogens because they just need 1 electron to do that, and their reactivity increases as you move from fluorine to iodine. The noble gases, they are extremely unreactive because they have a completely filled outer energy level, Helium is the only noble gas with 2 valence electrons, and then the rest, they have 8 electrons. You can see this from your periodic table. Few compounds with Kr and Xe, xenon unknown, indicating that reactivity increases down the group. So if you look at your Kr and Xe, they are further down the group in group 8. So this means that as you go down the group, reactivity increases. Now we can do end of chapter example problems. We are done looking at the periodic table. Let's look at an example on thread in groups. The elements nitrogen and phosphorus. Nitrogen and phosphorus, they are both in group 5, are in the same vertical group and have the same number of valence electrons. Give a reason why a phosphorus atom is larger than a nitrogen atom. So why is phosphorus larger than nitrogen? Phosphorus has a total of 15 electrons and its valence electrons are in the third energy level. So phosphorus is in period 3 and nitrogen is in period 2 in the periodic table. If you look at your periodic table, so then nitrogen has only 7 electrons and has 1 less energy level, because remember I said as you move down the group you are actually adding an energy level. Each time you move down a group you are adding an extra energy level. So nitrogen is at the top and phosphorus is at the bottom of nitrogen. So nitrogen has 1 less energy level than phosphorus. The valence electrons of phosphorus are further from the nucleus than those of nitrogen. So if you think of the circle, again, the circle of people dancing, the valence electrons of phosphorus, so the circle of phosphorus is much more bigger than the circle of nitrogen. So the valence electrons of phosphorus are much more shielded by the inner electrons compared to the valence electrons of nitrogen. Therefore, phosphorus is a larger atom. So phosphorus is a bigger circle than nitrogen because of that. Question 2 is based on trends and periods. The element nitrogen and oxygen are in the same period. Yes, they are, which is period 2. Oxygen has 1 more proton and electron than nitrogen. Both atoms have electrons in the same energy level. An oxygen atom is slightly smaller than a nitrogen atom. What is the reason for this? First of all, an oxygen atom has a greater nuclear charge than a nitrogen atom. So its nucleus attracts the electrons more strongly than the nitrogen atom. Therefore, an oxygen atom is slightly smaller than a nitrogen atom. Because remember, if your nucleus attracts the electrons more strongly, it means that if the people at the back of the circle can clearly see the person who is dancing, it means that the circle is not big enough. So that is the case with oxygen. The circle of oxygen is not big enough, so it is smaller than the circle of nitrogen. Ionization energy. Question 3 is based on ionization energy. The general trend is that the first ionization energy increases from left to right in the period. That is from lithium to neon and from sodium to argon. What is the reason for this? The reason is that the atomic radius decreases from left to right in the period. The number of electron energy levels remains the same while the nuclear charge of the atoms increases. What happens if the nuclear charge increases? The valence electrons are attracted more strongly to the nucleus and more energy is required to move an electron from a neutral atom. Therefore, the ionization energy of the elements increases. So you need to know how to explain these trends. But you have it in your lecture slides. You have everything in the lecture slides that I made you. So if you just go through everything and try to understand everything, then it will be much more easier to explain these trends. It is not hard, trust me. Let's move on to an example on electronegativity. The element fluorine has a very high electronegativity value of 4. What is meant by this? So what does a high electronegativity of fluorine means? Electronegativity of an element shows how strongly an atom in a compound will attract a shared pair of electrons towards it. So what this means for fluorine is that a fluorine atom will exert a very strong force of attraction on the valence electrons of a neighboring atom and will attract these electrons towards it. So if a fluorine atom reacts with a less electronegative atom, it will attract the electrons of that atom towards it. So that's what a high electronegativity value means. So it means that because fluorine, if you look at fluorine, it actually in the periodic table has the highest electronegativity value. So it means that fluorine, when it reacts with other elements, it is going to attract the electrons of those elements towards it. That is it on this video. On the next video, we are going to start on a new topic, chemical bonding.